Thank you. So up here on this spreadsheet is a description of the story and problem statement that we started with, and we've actually iterated it a bit while working on it today in Python. We started off with the question of in which United States metro areas might a solar economic boom occur, and we were looking at that through a couple lenses. First of all, we were looking at Yale's data on public perception of renewables and picking out indices that show that in a given state, there is strong support for renewable energy. And then we were also looking at a website called Desire, which catalogs state incentives on renewable energy. So that was what we started with. We started thinking about it from a metro area focus. And then we moved to a state focus because what we found is that both database sets that we were looking at provided information for states, but not necessarily in terms of breaking it down by metro area. So we also looked at another report by Clean Edge, which we decided not to include for the time being, but they do talk about metro areas as well as states. So we had some questions about their data that we'd like to resolve before proceeding. So to begin with, we looked at data from Yale University. They recently published a set of maps which describe people's perceptions of climate change and also renewable energy issues. And if you use this pull-down menu, you can see that support for requiring utilities to produce 20% of their electricity from renewable sources, which is the index that we chose, is fairly high. This should update in a moment. Let's see. All right, so it looks like for this graph, most states, with the clear exceptions of Wyoming and West Virginia, are in, let's see, above 50% range of support, going up to some higher percentages there as well in places like California, New England, and Washington. So we took this data as our base spreadsheet. There is a feature on here under Methods and Data up at the side where you can export this information as an Excel file. And we took that, we combined that then with some information from the Desire website, database of state incentives for renewables and efficiency. And if you scroll down a little bit on this website, you will see that we have many options here for finding policies and incentives. And there's also an Excel spreadsheet that you can download from this web as well. So putting that all together, we looked at some charts from this website that outlined a few different variables. First of all, we looked at power purchase agreement legislation. We looked also at renewable portfolio standards. And then we looked at net metering policies. So of those three variables, we chose to focus on the net metering, which is a solar-friendly policy, and power purchase agreements. Net metering has been particularly controversial recently, so we thought that would be a good one to look at. And we decided to not focus on renewable portfolio standards because that didn't seem to be quite as cutting edge of a topic, so we focused on the other two. So we made a spreadsheet that included these different pieces of information, and then we went to work with Python. So let's see what we have here. So this is the outcome that we produced. Let me scroll up a little bit so that you can see it better. So we did a few different things to produce this map. We set up our variables. I'm not going to go through all the specific details of how we did this. We created the map template within Python, and we brought in a color tool that allows us to use a pull-down menu to pick a variety of colors that we can assign to the map. And then we also are able to assign different variables to the map. So in this case, the variable that we chose is public sentiment in favor of 20% renewable energy from utilities. and that's the one that we are depicting right now. But we could very easily look at other variables as well. And what we're planning to do, if we follow up with this, is to do a composite variable that describes the combination of renewable energy friendly policies. So that would be the second item that we would chart. We might also individually look at those different variables in their own charts. So that's what we're thinking about in terms of putting this all together. And we are talking about what to do next in terms of possible future steps, maybe doing a pitch and isolating the states that are most likely to be hotspots for renewable energy activity in the future based on their current policies and also based on public support for renewable energy. So I'm welcoming questions. Certainly. She's interested in hearing more about how we made the map. I'm going to scroll up and show you how that process worked. All right. So here in item 1, we imported some options that allow us to work with Excel material. So let's see, Pandas is a particularly important tool that we're using, and we used Seaborn to work with the map. So then, moving right along, this YPCCC file that we read in step 2 is the CSV file that we are using. And then this printout here right below this in number 2 shows some states and some data from the spreadsheet. This just confirms that we're getting the right information in. And we set an index called state name and brought in the abbreviations for the different states. And then we imported a tool called JSON, which allows us to work with the map. And the JSON file is in the same file as the map files are located. That's JSON. And then we have a function here called drawState, which draws the states. And then right below this, there's a function called makeMap. We added a color feature to the makeMap. These are functions that we found online by Googling. We looked up the JSON feature. We looked up the coloring features, which I'll show you in a minute. And we also looked up the map feature, I believe, as well, too. Rahul can provide some more details on the mapping process. There it is. GitHub.com, data, IAP, etc. That's the URL. I can leave that up there for a minute if you want to write it down, or else I can scroll later. Okay. Okay. Yes. So after the makeMap function, which we added a color feature to, that's this CoMap. Then, let's see, this is the makeMap function continued. And then, let's see, we defined these headers. And here's the makeMap command, which puts it all together. And as you can see, there's a variable called futureGen that's being plotted here. And that is people's sentiment about future power generation. And that was what we took out of the spreadsheet that we imported. And then the second item here, public sentiment in favor of 20% renewables, is the header that I have in there as a placeholder. And my CMAP is the color variable. So scrolling down a bit further, you can see that this, first of all, this image here can be screen captured or it can be dragged onto the desktop. And if you go down a bit further, you can see how my CMAP, the color variable, is defined. So this sort of long description here, choose color brewer palette. This is something we found online. So color brewer palette is an online Python basically description that you can use here, and we assigned it to be sequential and set this CMAP variable to be true. And then what you get is this opportunity to pull down a menu and select your color scheme. So you can pick oranges, blues, etc. If you change this N, it will change the intensity of the color. And if you adjust the DSAT variable, then you will have a different number of colors shown, I believe. Or actually, no, the DSAT variable is the one that changes the intensity, and the N is the one that sets the number of colors in the gradient. So that's everything that you need to put this together. And it looks really good. If we looked further, we might have been able to find a multicolored option to, go from, say, red to blue or red to purple. That might be interesting too for sort of heat map type appearance. So, other questions?